Stanisław Barszczak, Wormholes and Black Ones, in search of tomorrow's silk. Dear friends, the world has gone crazy again. We fly to the moon and to Mars. We explore the structures of the megacosmos. We are delighted with the achievements of modern physics, the theory of relativity, and the quantum theory. As part of the latter, going deeper into reality, we are by no means able to cross the so-called Planck's threshold, where time does not exist, only energy and elementary particles. All the laws of no physics break down here. Planck's constant is a quantity characteristic of quantum mechanics, determines the relationship between the wave and corpuscular properties of particles. The momentum p of each particle corresponds to the wavelength lambda h equal hp, introduced in 1019. We do not have accurate information about the cosmos. In 2009, NASA agencies launched the Kepler probe, which found better planet to live in than the Earth. The Webb probe is supposed to change that, but there is always a limit to that. Even Einstein's theory of space-time gets lost in the vast cosmos. They remain unknown something. In modern physics, which have covered an unprecedented multitude of phenomena, we go not only forward, getting to know the beautiful universe, but we can go backwards or deep into reality, into subatom reality. Let's compare the work at CERN, a laboratory near Geneva, with the so-called standard model of elementary particles. Modern atomic clocks make life on Earth easier for people, GPC, by merely measuring physical reality. Perhaps the entire cosmos is physics. Well, even quantum mechanics is not responsible for its revelations. With the discovery of gravitational waves in colliding black holes, we have made some progress in understanding the cosmos. But some malcontents talk about saying goodbye, about parting with this Big Bang theory because we can live in a black hole. You know, scientists are not now observing quasars. It is a star-like object emitting radio waves, a compact source of continuous electromagnetic radiation of enormous power, seemingly resembling a star. In fact, it is a kind of active galaxy. Quasars appears when the powerful gravity of supermassive black hole in galaxy's core pulls in the surrounding matter, which creates a disk of superheated matter circling around it. This process releases huge amount of energy, which makes the quasar extremely bright and often outshines the rest of the galaxy. Not everything is eaten by a black hole. For example, it will not eat a quasars. However, the radiation here is huge, even X-rays and radio wave. The earliest quasar known to science from 13 billion light years ago has become a quencher of star formation. Scholars are watching two pulsars. Neutron stars act as beacons first discovered in 1967. They create new conclusions. Space is beautiful. Let's get to know modern physics. It's great adventure of humanity. Gravity is the shape of space-time. The latter are three spatial dimensions and time, which we treat as the fourth dimension. What we commonly call time is encoded in spatial configurations. If so, there is no point in referring to something external. Space is sufficient glue to join objects together. As believers, we state time was created by God, who is beyond it. According to Kant, transcendental aesthetics, time and space are a priori form of our sensuality. They originate in the subject and apply to all phenomena. Let us return to the concept of space-time, because each mass leads to the curvature of space-time. It causes a depression in it, stretching both three-dimensional space and time. In the era of high technology, people dream of gravity, of lightning fast travel through space, but this is an unstable picture of the cosmos of today. Let's imagine a two-dimensional plane, for example, a stretched rubber membrane. If we put a heavy ball on it, the surface will bend and smaller balls nearby will be attracted to the larger one. The same thing happens in the universe, except that the membrane is four-dimensional space-time. Extremely strong curvature of space-time occurs in black holes. Black holes form when a massive star dies. The region of space-time they occupy has a gravity so strong that nothing, including light, can escape it. Surrounding a black hole is a surface called the event horizon, which marks the boundary of no return. Even more extreme conditions prevail inside a black hole. Its gravity probably squeezes all matter and energy into a single point. The curvature of space-time becomes so huge here that the so-called singularity. Black holes have another remarkable property. They show what is happening on the side physically further away from the observer. We will see our backs. Observing massive objects circling around each other, scientists discovered that in the vicinity there is not only a curvature of space-time, but also its pulling or dragging. This effect consists in the fact that the rotating body drags space-time behind it like a spoon in a honey. Mass not only bends space-time, but also twists it. Therefore, space-time around massive bodies should both bend and spin at the same time. It is a fact that gravity-induced slowdowns have already been observed, slowing down the passage of time near Earth. It was also possible to prove that there are gravitational waves, i.e. waves of space-time itself. They are caused by the colliding black holes described here. For example, objects that bend space-time so much that nothing can escape from their vicinity. Based on space-time, Einstein's notion of space and time, physicists are planning a so-called wormholes. If, for example, we make a balloon-shaped depression in the sheet and bend it, we can shortcut to a very distant place. It seems that even black holes will not save us, I would say here. What is a black hole? Is a region of space-time from which, due to the influence of gravity, nothing including light and information can escape. A black hole is a place you can fall into from any side. According to the general theory of relativity, for its formation it is necessary to accumulate enough mass in a sufficiently small volume. In the general theory of relativity, which does not take into account the effects of the quantum field theory, black holes can only increase their mass, and for this reason they do not end their existence. But the physicists of this day intend to build a unification of the theory of gravity with the quantum theory of quarks, which was initiated by Hawking's concept of the existence of black holes. Stellar mass black holes are formed by the gravitational collapse of very massive stars and the end of their lives. Black holes are formed from stars, I said. The star is subject to the influence of two opposing balancing forces: gravity, the gravitational field, trying to squeeze matter to the central point, and the pressure of hot gas, trying to push the star apart. The event horizon of a black hole is the border beyond which there is no return, I said. Everything that exceeds it disappears forever from our universe. On the event horizon, the force of gravity is so powerful that there are no mechanical forces that one can overcome it. Inside the black hole, there is no matter that would have any density. Its interval is a vacuum. Everything that falls into it eventually ends up at the central singularity, the point where all known physics breaks down. Hawking showed that a black hole can evaporate, gradually transforming itself and everything it swallowed into a featureless cloud of radiation. During this process, information about anything that has fallen into the black hole is lost, which violates a sacred principle of physics. Finding and studying black holes and neutron stars in our galaxy is crucial for space and scientists because it tells them about how they form and die stars. Beloved, for my part, I encourage my readers to be courageous and in conquering space, but also to show greatest solidarity in the third millennium of technical civilization in the matter of averting earthly cataclysms, respecting the weak and firmly adhering to the most human values.